We had, let's see, we had, come on, baby. F at x is equal to 3x minus 1. And then we have g at x, which is equal to x squared plus 5x minus 7. So the first one is they said, hey, what is, for number 6, what is g at 2? Or g at negative 2, excuse me. So we're going to use this equation. So I get negative 2 in parentheses. The reason I put that in parentheses is because algebra 1 mistake, you forget to square a negative. So that gives me 4 minus 10 minus 7. That's a 7. It's trying to be. So 4 minus 10 is negative 6. So I think negative 13. Oh. For the equation, so you go through and just do the arithmetic. And so what this really means in the justification of the problem is if you had graphed it, this point exists on the graph, which is not an x-intercept or anything like that, but it's just that point exists. So then number 7 says we want to g at x minus f at x. Okay, so g at x is this. And then I want to subtract this from it. So I'm going to put this in parentheses so you don't forget to distribute the negative over. And then combine like terms. Those are like terms, so I get x squared plus 2x minus 6. Cool. And then it starts getting to the different stuff where we're taking a whole bunch of stuff and plugging it in. So, oh, are you guys done? I'm sorry. Everyone okay? So number 8, they would like us to do g d plus p, which means my g at x equation was x squared plus 5x minus 7. So I'm going to take d plus p, bless you, and replace it there and there. But then I have to use the arithmetic to make it a little bit better. All right, so I have x squared, which is going to be d plus p in there, plus 5 parentheses d plus p minus 7. So you do a little bit of math, realize d plus p is d plus p times d plus p, FOIL, so dd plus pd plus p squared. Oops. Just do that one, and then plus d squared. We have 2 PDs, so d squared plus 2 PD plus d squared. That replaces this. And then distribute over the parentheses, plus 5d plus 5p minus 7. Take a look if you have any like terms. Hello.
How you doing? Sorry for not being in yesterday.
Okay.
I was with the Marines.
You found a pen?
No, the Marine.
You went to the Marines. Yeah. Nice. Congratulations. Did you sign it?
Yes, I still don't have a green card.
Uh-huh.
You don't have a green card? I came here like 2 months ago. Oh, that's not a
Sweet.
I was going to say, how are you here?
Yeah. But you're going.
My dad has a work visa.
Yeah, but you're going to serve for us. Thank you. I thank you for your service, my friend. All right. Number 9. This is where we want to replace a few things. Minus f at x over h. So my equation was f at x equals 3x minus 1. So what I'm going to do is I need to replace this here, and then I need to subtract that equation, then divide by h. So I'm going to get 3x plus h. Thank you. I lost train of thought. I don't know what happened. All divided by h. Distribute over the parentheses. Distribute the negative over the parentheses. So I'm going to get 3x plus 3h minus 3x minus 1 all over h. Combine like terms. So this cancels this. which then yields me up to 3h over h minus 1. Hang on, I made a mistake. Oh, there's a minus 1 here, huh? And then there's a minus there. So there should be a minus 1 there. Is that what it is? Okay. And then that should be a plus 1. Okay, there we go. Oh, I knew I wasn't getting the derivative right. Those cancel out, so that's gone here. So we get 3h over h. So that means that the answer results in being 3. Okay, so that's the definition of finding a derivative. Derivative is lowering the dimension that you are currently in. It's really all it does, but it finds things in calculus and it finds things in physics. If you ever get to take the calculus-based physics class, you will love it. Make sure you take calculus first. Do not take it concurrently. There's a whole lot of people like, oh, I'll just take Calc 1 and calculus-based physics at the same time. Take Calc 1, 2, 3, then take calculus-based physics. If you plan to go that route. All right, and then number 10 says find the exact value of x when g at x is equal to 0. So all that is really doing is using Desmos. Let's see, go to Desmos. So when it says it's equal to 0, that means it's going to cross the x-axis. And they're asking for the exact value. So I want to take a look at this first because this might not give me the exact value. So I get y equals x squared plus 5x minus 7. So you get here and here. My friends, those are not exact answers. So if they're going to ask for the exact answers, that means we have to do one of two things. We could use the quadratic formula, which is a gimmick, or we could complete the square. I personally would like us to focus on completing the square. It's much more usable. So if I have this, yeah, it's much more usable applying in other math and higher level classes. Oh. All right. So good way to do this. I can make it equal 7, leave the space. I have parentheses. This addition sign needs to come down. This is a quantity squared. So you take half of 5 over 2, or you take half of 5, which is 5 over 2, and then you would square it. So 5 times 5 is 25. 4 times 4 is 4. So you add 25 fourths to both. This right here is what is called the complete square. Okay? So this is always half or divided by 2, and this is always this squared. So need to get a common denominator. Let's see, that's going to be 28 over 4 plus 25 over 4. If I add those together, that's going to give me 53 over 4. And then you have to remember the math. Let's get a nice color. Ooh, let's go with hot pink. All right, root. Don't forget plus minus. Then you get x plus 5 over 2 equals plus or minus the square root of 53. Square root of 4 is 2. So you no longer have a radical on bottom. So your answer comes out to negative 5 plus or minus root 53 all over 2. That's the same answer you would have gotten if you'd used the quadratic formula, but completed the square. The better you get at that, do it in a class that's a non-anxiety class. Learn how to do it in a class that's a non-anxiety class. So completing the square is just a good thing for you to use as practice. Okay? All right. Does anyone want like a step-by-step of completing the square so you have it as a pattern? We already did it? All right. So let's do this though. So let's do this. This is how you complete the square. If you've seen this before, good for you. Ax squared plus bx plus c is standard form of a quadratic. If I wanted to complete the square with this, you divide everything by a first because you want your lead coefficient to be 1. So you get to that. You want to start solving it for x. So I'm going to move c over a over here by subtracting it. So in parentheses, I'm going to have x. That plus comes down. Half of b over a is b over 2a. If I square this, you get b times b, which is b squared. 2a times 2a is 4a squared. If I add b squared over 4a squared to one side, I have to add it to the other side, so I get there. So this, if I FOIL this out, I get this. Following so far what I'm doing?
On the right, it's b squared, right?
Yeah, yes it is. Yes it is. I just thank you for helping me out. That should be b squared. All right. So rearrange the order of this, make it b squared minus c, or yeah, b squared over 4a squared minus c over a. Get a common denominator. So I'm going to multiply this by 4, multiply this by 4, multiply this by a, and multiply this by a. So that's then going to give you x plus b over 2a, quantity squared, equals b squared minus 4, and then change your letters around, flip-flop them. Root, because I want x by itself. Don't forget plus minus. So that gives me x plus b over 2a equals plus or minus b squared minus 4ac. Square root of 4a squared is 2a. Subtract b over 2a from both sides. You have to have common denominators. And lo and behold, what do I have?
That is z.
A on bottom.
Yeah, what's the first one?
A. That's minus 4ac.
Oh.
So this is the quadratic equation, which you might know the song x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. That's how it comes about. You can actually go much further than this if you are a very twisted individual. You can actually solve this for x equals, and there is a cubic equation that happens with it. We don't have enough time to go through it. Yeah. This one? All right. So you're telling me when to stop going down. Okay. Where are you at? Am I yellow highlight or no? Huh? Okay. So I had subtracted c over a from both sides, so that's why it's minus c over a on the right side. I left a blank. So underneath my first yellow, I made the second yellow. I go x in parentheses plus, the plus sign always has to match. This has to match this. Okay, that sign has to match. And you take half, meaning you just multiply the denominator. That's where that 2 came from. If you square this, if I go b over 2a squared, that becomes b squared over 4a squared. So that's where this came from. So if I were to take x plus b over 2a times x plus b over 2a and FOIL it together, I'd get x squared plus b over a x plus b squared over 4ac, or b squared over 4a squared. And then it's just a matter of manipulating the problem around. And you are able to define the quadratic formula based on that. Don't worry, I'm not going to make you prove the quadratic formula. But for those of you all who like money, if you were to solve this and you find out that x, y, and z are whole numbers, this actually was solved. This is called Fermat's last theorem. And he proved how you can make this work with a quadratic formula. I believe the prize money for this was just north of $9 million if you could solve it. And there was a couple of kids at Princeton University that were PhD majors in math that solved it. And from I believe it was the German government that had a $9 million reward. Basically, by solving things like this, to get to this, allows you to unlock any computer program.
Really?
Yeah.
I can become a hacker with that.
Yeah. I mean, you have to understand programming, obviously, but is that because people are hacking into like an iPhone or?
Yeah.
That is kind of freaky. I don't know. I'd have my phone pointed at me while I'm doing dishes, but it's also kind of like, we wonder why if we talk about dog food, and all of a sudden we go on our social media and it's like there's a dog food ad.
Yeah.
It's like, don't worry, they're not tracking you. You sure? All right. So let's take a look at these bottom couple problems here. We can easily solve those, putting them back into standard form. So why don't I pick number 14 to do? Make sure you know how to do it. We'll take a look at this. Number 14 on that page, we have -3, and we also have 2 over 3. So we want to put this as ax squared plus bx plus c, where we have a, b, and c. So I'm going to say x equals -3 and x equals 2 over 3. And we've already done quite a bit of this. This binomial is x minus 3. Multiply both sides by 3 here, so I get this. So this is the binomial that goes along with this. And I'm going to FOIL these together, or multiply them together. So x times 3x is 3x squared. X times -2 is -2x. -3 times 3x is -9x. And -3 times -2 is +6. And here comes... Oh, there might be a fakey one coming. Nope. I feel blessed, though. Thanks, guys. All right, these are like terms. So I get 3x squared minus 11x plus 6. So this is the quadratic that would have these as our solutions, or where they would cross the x-axis. Okay? So I think you should be able to handle doing the rest of those. Let's flip that page. Number 15, decimals problem. Agree? Find all the zeros. That's where it's crossing the x-axis. And these are just distributing over, combining like terms, FOILing and things like that, and take care of all that. This one definitely use on Desmos. Type it in as it is. You're solving the points and the x comma y value. And then let's take a look at the very bottom ones to see how we can play around getting the domain. But we're going to use Desmos for us to get the domain. So let's see. We have letter A at the bottom, which is root x minus 4. Letter B. Is letter B the third root of x?
Yeah.
Thank you. Letter C, is that 3 over, what is C? X minus 9 on bottom? X minus 8 on bottom, thank you. Letter D, we have square root x squared minus 16. And then letter E, is that, what's the number on top?
2.
2 over what? X squared minus 1, 9?
Yes.
Cool. All right, so we're going to use Desmos to get our domains for each of these. So the first one, square root x to the 4th. So the nice thing on Desmos, if you go down to your keypad, it has an awful lot of stuff. So I find the square root, and I have x minus 4. So if you come out, you notice, oh, it's minus 4, right? Ooh, watch it shift. So come down here. If you click on this point, that means that point truly does exist. Okay, you can have the square root of 0. Square root of 0 is 0. So the domain of this particular one will go from 4 to infinity, because if you zoom out, this graph continues forever. So utilizing Desmos to be your friend, we're going to say that our domain on our this is a hard bracket from 0 to infinity. Hey, good to see you. Give me some love. Gotcha. Okay. If you look, we're on the back side of the second review. Third review. Thank you. I just make errors all the time. I don't know where I'm at anymore. All right, so if you wanted to graph this one, Desmos will indeed take care of a third root for you. So y equals, and look for the third root. Let's see. You might have to go under functions to find it. I just can't remember where it's at. There it is. So under number theory, you do the nth root. So I want the third root here of x, which becomes this squiggly line. So that goes forever to the left, forever to the right. So the domain of this particular one will go from negative to positive infinity. And so square bracket is used there because x can indeed equal 4. That exists for the problem. The soft brackets, or the parentheses, we never can get to infinity, so we always use soft brackets there. Okay? Anyone know on number C what's the only number that we can't plug in to make work? And why?
-8.
Close. What makes it 0 on the bottom? Positive 8, yeah. So positive 8 is the only number that wouldn't work because you're dividing by 0. Because 8 minus 8 is 0, so 3 divided by 0 is an undefined term. So if you look at this one on Desmos, Desmos will handle it really nicely. So y equals 3 over x minus 8. So 3 divided by, and then x minus 8 on bottom. So you get this nice looking situation. So things to know. If I did the equation x equals 8, it's a vertical line. That's the only value that won't work on this problem. So we will go from negative infinity all the way to positive 8, and then from positive 8 to infinity. So we have to make sure we're using So it goes from negative infinity to 8, and then 8 to infinity. And that basically means that the only value that wouldn't work, we'd approach from both the left and the right side. In the world of calculus, and we'll start dealing with limits in a little bit, this is a limit problem where we are approaching from the left side to the right side. How do you know if the limit exists? Those are things that we'll talk about later. Yeah.
Why isn't it closed brackets?
Because I can't let it, if it's a closed bracket, it means it equals 8. The soft bracket means I come close to it.
Okay.
I like do a close, remember you have little brothers or sisters or older brothers or sisters. One brother or sister doing this, it's like, Mom, so-and-so's touching me. I'm not touching them. They get like infinitely close to you.
Okay, how do you know if it's,
What would,
zero?
okay, what would make things, so if x equals 8, we would get an undefined term because we're dividing by 8.
Okay.
Or dividing by 0, excuse me. So that anytime you have an undefined term, that's going to result in using soft brackets because it's close to it. It's not quite there. So I'm not sure at calculus if we teach something called the Fly-Swatter theorem. That has to do with limits when you're approaching things from the right and the left. I don't know why they call it the Fly-Swatter's theorem. All right, this particular problem, this is going to look pretty unique. So we should not get a negative number under the square root to have it be part of the real number system. So if I graph this, this is going to look like a little goofier graph. Let's get rid of this stuff. So I have the square root of x squared minus 16. So look at that wild looking graph. Like, what shape is that? I don't know. So I will tell you that these two values do indeed exist because I can have the square root of 0. That's fine. Anything from -4 to +4 does not exist in the real number system. It exists in the imaginary system because you are dealing, or the complex number system, because you would be dealing with a negative square root. So in order to make this work in the real number system, I can use square brackets on those 4s. So this is going to be negative infinity to -4 square bracket, and then square bracket from 4 to infinity. That basically means we would exist, our graph exists in the real number system in those boundaries. Anything between -4 and +4, so -3, -2, -1, 0, 1, 2, 3, or any of the fractions or decimals that exist between them, those would not work as far as the real number system. Okay? Question so far? I know I kind of went super weird, fast, freaky stuff. Let's take a look at that last one. I get 2 divided by x squared minus 9. So look at this fun show. Okay, pretty goofy looking problem. Okay, so the values that would make this denominator 0 are +3 and -3. Okay, so if I looked at these lines, x equals 3, and I looked at x equals -3, okay, those vertical lines don't exist as far as the problem goes. Those are the undefined terms. Okay, so my domain of this one is going to go from, it's going to go from negative infinity to -3, goes from -3 to +3, and it goes from 3 to infinity. This means that this 3 here, all of these 3s, we get really close to, but they can't be part of the answer. But they are part of the domain where we exclude them from the domain to give us that. Okay, so what review are we on? Okay, finish, review 3, and we'll go over tomorrow, and that will be, I believe, your second assignment. Cool? Everyone happy?